Hello and welcome. This is George B. Smith. Okay, now today we are going to be talking about integral calculus. Okay, now this is the first series I'm making on mathematical concepts. Okay, and I'm actually starting with integral calculus for a particular reason. Now I know I would have gone ahead to look at derivatives first, functions, and the rest of that, but um, there's a pressing issue. That's the reason I decided to start with integral calculus. So this is the first video in this series. Now in this video I'll be taking you through the course content, the overview, what you should be expecting. Okay, so that even at this point you should know that by the end of this course you should be grounded in these particular areas that I'm going to show to you guys here. So the first thing we are going to look at is the concepts. Okay, concepts in general. What's the concept behind integration? What's the big picture? What can you do with integration? That's the first thing we are going to look at. After that, we'll come to standards. There are some basic standards we have in integration. Now, these standards, they are actually derived from what you have in derivative, okay, in differential calculus. Once you understand differential calculus, trying to reverse the process is what we have in this standard. So it's more like it's going to be a table or a list of things that are meant to be. That's what we call the standards. Then in the third section we are going to look at some forms of integration, okay, where when you see a particular integral, how can you easily detect what the answer should be? What's that particular form? That's what we are going to look at in the third section. Thereafter we'll come into definite integrals. Okay, this is where you get to understand that there are two kinds of integrals. We have the definite and indefinite integrals. Generally, whenever people look at integration, they talk about indefinite integral. That's the general concept. Okay, but now trying to apply to real life situation, you hardly work with indefinite integral. You come to definite integral because you want to know the final result you're going to get. What's that constant, okay, that is going to be reasonable or useful. That's what we'll look at in definite integrals. Then we'll move down to the techniques of integration. Now there are different techniques of integration. The first one we are going to look at is integration by algebraic substitution. Algebraic substitution is also called change of variables. Okay, you want to change a variable from one, maybe from x, since we are so used to x, we want to change it from x down to some other variable, usually u. That's what we look at in algebraic substitution. Then under techniques of integration, we still have integration by parts. Now in integration by parts, I'll be showing you different ways. Okay, the normal method we know of, which is using the integration by part formula. They'll move down to what we call Leibniz rule of integration. Use a shortcut we have there called the DI method, which makes integration by parts quite easy, especially for some long integral or difficult integrals you're going to see. Then we move down to integration by trigonometric substitution. So when it comes to integration by substitution, we have different kinds. The first one we looked at, I just mentioned, is integration by algebraic. This is trigonometric substitution. It's also change of variable. Okay, also change of variable. Then thereafter we'll go into integration by hyperbolic substitution. This is where we try to work with hyperbolic functions. That's what we are going to work with here, hyperbolic functions. Then thereafter, this is meant to be the 9th section, not the 8th, the 9th section. This is going to be integration by partial fraction. Okay, the 8th section is integration by hyperbolic substitution. This is the 9th section. That's a mistake. It's integration by partial fractions. Okay, then we'll move down to the 10th section. This is the 10th section, which is integration of power trig functions. Thereafter, this is the 11th, also a mistake. This is the 11th part. We look at solving different kind of questions that we have to apply two or more of the techniques we've just discussed. Okay, so that's what we are going to look at here. We're basically going to look at some of that things they call miscellaneous substitution that we didn't mention among the different kinds of substitution. So that's what you should be expecting. Okay, and it's going to be intensive because we are going to be solving a whole lot of questions. Okay, now I'll try as much as possible to make every video to be quite short, okay, so that you grasp the concepts, you try questions on your own, the next video comes along, you go ahead and also understand that concept before moving on to the next one. Okay, so that being said, that's what you should be expecting. We have 10 sections in all. The 10th section is actually going to be versatile. It's going to cut across all the other 9 sections we have. Okay, go ahead and place your comments if you have any issue based on what I've said, or if you have maybe there are some things you have issues in and you want me to add it to the content based on what you've seen here. Maybe you don't have that among this content. You can go ahead and put it in the comments. Okay, I'll see you guys in the next video. Bye.